In this lecture video, we will talk about software maintenance. What is software maintenance? Software maintenance is the general process of changing a system after it has been delivered or put to use. This term is usually applied to customized software in which separate development groups are involved before and after the delivery. Now, there are three types of software maintenance, and they are listed on the slide. First one, fault repairs. Coding errors are usually relatively cheap to correct. Design errors are more expensive as they may involve rewriting several program components. Requirements errors are the most expensive to report and repair because of the extensive system redesign and implementation that may be necessary. So, fault repairs are about corrective maintenance or correcting errors. And as we already know, coding errors are least expensive to correct because coding happens or the implementation is almost at the end of the development phase, and you would have your requirements and design correctly in place before you start with implementation. But if you find out requirement errors at the end of the development or during implementation, they are going to be the most expensive to correct in terms of cost and time because you have to start right away from scratch. The second type of error is environmental adaptation. So the second type of maintenance is environmental adaptation. Now, this type of maintenance is required when some aspect of the system's environment, that could be hardware, the platform, the operating system, the support software, changes. That means the system environment changes. Then you require this kind of maintenance in order to adapt to the changing environment. The application system must be modified to adapt to cope with these environmental changes. The third kind of maintenance is functionality addition. This type of maintenance is necessary when the system requirements change in response to organizational or business change. The scale of the change required to the software is often much greater than for the other types of maintenances. Now, corrective maintenance is universally used to refer to maintenance for fault repair. So, fault repair is also called as corrective maintenance. Adaptive maintenance sometimes means adapting to a new environment and sometimes means adapting the software to new requirements. So, environmental adaptation is also called as adaptive maintenance. Preventive maintenance sometimes means perfecting the software by implementing new requirements. So, functionality addition is also known as preventive maintenance. Now, on this slide, you see two figures here. Now, this first figure indicates an approximate distribution of maintenance costs based on the different types of maintenance. The specific percentages will vary from one organization to another, but universally, repairing system faults is not most expensive maintenance activity, as you can see here. Evolving the system to cope with new environments and new or changed requirements consumes most of the maintenance cost. So, fault repair comes with the least maintenance cost, and environmental adaptation is almost likely the same, more or less the same. And the most expensive is when a functionality addition is required, or when the system requirements change in response to organizational or business changes. Now, this part of this figure shows the overall lifetime costs of the maintenance, or I should say, maintenance effort distribution, how it is distributed throughout the lifetime of the system. So, this is the overall lifetime cost, and you can see it may decrease as more effort is expended during system development to produce a maintainable system. So, these are the development costs given here in a darker shade of blue, and the maintenance cost in a lighter shade of blue. So for system 1, you can see that the development costs and the maintenance costs are somewhat equal. But here you can see that the maintenance cost is distributed over a larger space in the lifetime of the system. It is usually more expensive to add functionality after a system in operation than it is to implement the same functionality during development. That is, once you deploy the system in the customer's environment or put it into operation, if you have to add functionality or make some changes, that is definitely going to be relatively more expensive than if you had to add the same functionality before the system was actually given or delivered to the customer. The reasons for this are stated here. First, team stability. After a system has been delivered to the customer or deployed in the working field, it is normal for the development team to be broken up and for people to work on newer projects. The new team or the individuals responsible for maintaining the system once it is deployed do not understand the system or the background to system design decisions as to why certain design decisions were made, because they were not involved in the development of the system. They need to spend time understanding the existing system before actually implementing changes to it. So that is one of the reasons. The second reason is poor development practice. The contract to maintain a system is usually separate from the system development contract. That is, there may be two different contracts signed with different teams. One team to develop the system and another team to maintain the system. The maintenance contract may be given to a different company rather than the original company which was developing the system. This factor, along with the lack of team stability, means that there is no incentive for a development team to write maintainable software because they are not responsible for it. If a development team can cut corners to save effort during development, it is worthwhile for them to do so, even if this means that software is difficult to change in the future because they are not being held responsible for maintaining the software system. The third reason is staff skills. Maintenance staff are often relatively inexperienced and unfamiliar with the application domain. Maintenance has a poor image among software engineers. It is seen as a less skilled process than system development and is often allocated to the most junior staff. Furthermore, old systems may be written in obsolete programming languages, and the maintenance staff may not have that much experience of developing in these languages and must learn these obsolete languages to maintain the system. The fourth reason for this additional expense is program age and structure. As changes are made to programs, their structure tends to degrade. Consequently, as programs age, they become harder to understand and change because you would have added new increments, made enough changes that changing it slightly more is definitely going to degrade the program structure itself. Now, some systems have been developed without modern software engineering techniques. They may never have been well structured and may perhaps optimized for efficiency rather than understandability. System documentation may be lost or inconsistent, or systems may not have been properly documented at all. Old systems may have not been subject to stringent configuration management, so time is often wasted in finding the right versions of the system components to change. Now, configuration management is an activity where you maintain multiple versions of your software system if you have made any upgrades. For example, you release one version, you test it, and you find that it needs to be changed. You keep the original version as it is. You make a copy of this version, update it, and this becomes your second version. And you continue in this way and you maintain different versions, with the last version being your most updated version. But suppose you have not done this and you have made all changes to the to one copy itself. And if something goes wrong or if a bug is detected after you have made changes, there is no copy you can roll back to. There is no older version which you can switch back to, and this becomes a problem. So this is about an introduction, a brief introduction to software maintenance, and what are the challenges with maintenance, and why it is relatively more expensive to change a software after it has been deployed to the customer's base.